I'm Joel Parker.
And I'm Ted Burnham. This is How on Earth for Tuesday, January 11th, 2011.
The planet Mars has always held a special place in people's imagination, whether its red color represented the blood of war, or people imagining they see canals or buildings on its surface, or its inspiration for science fiction stories of aliens destroying the Earth. Once we started visiting Mars with orbiting spacecraft and rovers, we not only learned more about it and the lack of little green aliens, but we also uncovered yet more mysteries and possibilities. A common thread among all these stories in the science of Mars has been the speculation, even hope, that there is or was water and life there, or at least maybe there once was life. And if not, then could it still support human life sometime in the future? Our guest today is particularly well suited to talk about the questions of life on Mars and the science on Mars, as well as the nitty-gritty details of planetary science aspects of the red planet. With us in the studio is Dr. Bruce Jakosky, who is a professor of geological sciences at the University of Colorado in Boulder, the associate director of the Laboratory for Atmospheric and Space Physics, LASP, and director of CU's Center for Astrobiology. And he also leads the Mars Atmosphere and Volatile Evolution Mission, or MAVEN, a nearly $500 million mission to Mars that is scheduled to launch in late 2013. Welcome to the studio, Bruce.
Thank you, Joel. It's a real pleasure to be here.
So let's start off with MAVEN. What is the MAVEN mission?
The MAVEN mission really follows on the interest that everybody has in whether there's life on Mars, what the history of the climate has been, and the potential interactions between life and its environment. Our goal is to study the history of the Mars atmosphere. We're doing it from a very particular perspective. We're trying to learn how much of the atmosphere has been lost over Mars' history to space. We're doing that by studying the upper atmosphere as this conduit through which the gas is lost.
So how can you determine the history of the atmosphere from present observations?
Very long-lived spacecraft.
How long?
Well, we're actually only going to be a few years, but we're going to look at aspects of the upper atmosphere today that tell us about what the history has been. We're going to study what the composition and structure of the upper atmosphere is, how it interacts with the sun and with the solar wind, and we're going to measure things that will tell us about the integrated history through time.
So it's the Mars sun weather environment, similar to maybe what we do with Earth-based Earth-sun weather?
The closest example would be space weather here on Earth, the interactions between the sun, the solar wind, and the top of the atmosphere. In Mars' case, though, since Mars doesn't have a magnetic field, those interactions result directly in loss of the atmosphere to space. And that's something that scientists have thought has been important, but we have so few measurements, we haven't been able to quantify it yet.
So Mars not having a magnetic field, it doesn't have a buffer like the Earth does for protection and for losing things.
Exactly.
So when was the mission selected?
I sort of lose track. I have gone back in my email records to see when we started it, and the first mention I can find of it is 7 years ago now. In another month, it'll be 7 years. So I've been working on it that long. We launch in another 2 years, 10 months, and 6 days.
You've got that down.
but who's counting?
Right.
And every day it gets 1 day shorter, which is shocking because we have a lot of work to do between now and then. It's a long process to get a mission going, and a competitive one. We competed with 20 other teams that wanted to fly the mission they thought was most important. And we had to get through a proposal, a competitive in-depth study, and then we were selected to move forward. But it was only late last year that NASA officially confirmed us for flight, where they make the formal commitment to back us and to continue the development all the way up through launch.
So late last year, you really got the green light.
That's right.
So that seems like, 4 years or so? That seems like a very short amount of time to build an entire space mission, the spacecraft, all the instruments, and all the people.
It's frighteningly short. We have a lot of work we're doing in the next now 2.5 years, or almost 3 years. We're still in the design stage where we're in the process of finalizing the design. Then after our review of the design this coming summer, we get into the build it stage, then the test it stage, then we stack everything up on the rocket and launch it.
It seems like that to build all the, how many instruments do you have on the spacecraft?
We have 8 scientific instruments, and then of course the spacecraft itself. We have to worry about the launch vehicle and the interface between the launch vehicle and the spacecraft, the ground system, so we can move the data around, move the commands around and process it. And we have to worry about the science team to make sure they're going to be ready for the data when it comes down.
So is this a somewhat shorter than usual time to pull a mission together?
It's actually the standard time. There are guidelines that NASA's put together based on now 50 years of experience in launching spacecraft missions about how long you need to do each phase. So we're very much on an appropriate schedule. That doesn't mean we have a lot of slack. We don't want to start too early because then we're paying people to sit around and do nothing. And we don't want to start too late because then we're frantic getting ready. We're right in that sweet spot of on track.
Are there any new technologies or devices or things that are kind of a critical, difficult thing to do? Or do you have everything pretty well in hand as far as you can get all things done on time?
Well, those are two different questions. One of the strengths of our mission concept when we first brought it forward was we had no new technologies we needed to develop. As we've seen with most recently, say, the James Webb Space Telescope or the Mars Science Laboratory, which are both under development, if you have new technology, it has the risk of getting bogged down, adding cost, adding delays. So our strength is we had no new technology. That doesn't mean it's straightforward. One of the things I've learned in the past few years is that when it comes to space, nothing is straightforward, nothing is easy, and if you get complacent, you're dead.
So you're the principal investigator. You're the CEO of the project in a way.
That's a good way to put it, because I'm at the head of the project, but that doesn't mean I'm doing all the work, fortunately. We have a lot of people who have experience in each aspect of what we're doing, the instruments, the spacecraft, and so on, and they all know what to do, and then we have a very experienced management team to bring it all together.
As the PI of a almost $500 million mission, are there any surprises, any things that you didn't expect? It's a big deal to lead something like this.
I wasn't that involved in missions before I became PI. I was involved as a scientific investigator, but I didn't build an instrument. I didn't have responsibility for any one particular corner. I think the thing that surprised me the most is that I didn't have a clue what I was getting in for. And unless you've done it, I don't think you can. The job is so poorly defined and so much up to the individual to make it what they want and to play it the way they want to, that you can't know in advance what you're in for.
So when you come up with a mission, NASA wants to do a mission to Mars, how do you figure out what scientific questions you want to address with that mission?
There's a couple of different answers. One is that the Mars science community has been a very integrated community, and over the past 10 to 15 years has put together detailed documents describing what the important science is. So if you're fishing around looking for an idea, all you have to do is pick up that document, look at the top of the list, and there's the important science to do. In our case, and I suspect in the case of each of those different missions who wanted to propose to this opportunity, I sat back and thought, what do I think the most important science is? Made sure it fell on that list, and then started talking with colleagues about how to put a mission together.
So when the spacecraft gets to Mars, it's there for a couple of years nominally, or something like that?
Well, our primary mission is 1 Earth year, but we have enough fuel to continue after that for about 6 more years. So we're hoping for a long and successful extended mission if the spacecraft survives.
Well, I know you're focused on this mission, but if it's 100% successful and achieves all its goals, what Mars science questions do you still see left unanswered?
Well, the big one sitting out there in the middle of the room is there life or was there ever life on Mars? And if we find that there was life, is it related to life on Earth or does it represent an independent origin? And the MAVEN mission doesn't answer that question, of course, but we get at the history of the climate and understanding if there is life, what is the context of those organisms?
So why is Mars the place where everyone thinks about going to look for life? Why is that the place where we're always talking about is life on Mars and go there and try to explore and find out?
Based on our understanding of life here on Earth, we can define a set of environmental conditions, requirements to be able to support an origin of life or the existence of life. And when we do that, they're pretty basic requirements. Mars meets those requirements or appears to meet them in places today or at times in the past. There are 2 or 3 places in the solar system that might meet those requirements, but Mars happens to be the closest one and the easiest one to get to, so it's gotten the most attention.
So it's the first place to look.
I think so. You would get disagreement from some of my colleagues.
What are some other places where we might look for life in the solar system?
Europa, where we think there's a global ocean underneath a thin ice covering. Titan is a very interesting place because there appear to be lakes covering the surface, part of the surface, although they're not lakes of liquid water. And we think that there's liquid water under the surface. That liquid water is the key. If we can find water, everything else we think will fall into place, and there's the potential for life.
So they talk about follow the water and things like that. So water is really kind of a key element in deciding even where you're going to look for life.
It's the first question you have to ask. Where's the water? And then if there is water, can life be supported?
So water isn't currently flowing on Mars, but what is the current status of present day or past water on Mars?
We see evidence that water has flowed over the surface in isolated places recently, and we also have evidence that there could be water beneath the surface today. And in the ancient past, there's clear indications that water did flow over the surface, that it was stable. So we have evidence for a long history of water at the surface or in the subsurface.
So are there, after MAVEN, are there other Mars missions already in the queue to look at some of those other questions?
The next mission after MAVEN will be a joint NASA-European Space Agency orbiter to look at trace gases. That'll tell us about the nature of the atmosphere and possibly about the presence of life.
Well, I wish you the best of luck, although hopefully it's all planning and not luck with MAVEN. And it's launched in
November 18, 2013.
So book your tickets now. It's going to launch out of Florida, I assume?
At Cape Canaveral.
Okay, so be sure to get there early. I'm sure you'll be there. Thank you very much for coming in and talking about Mars.
Thank you for inviting me.
Thanks a lot, Bruce. We were talking to Bruce Jakosky, who is the principal investigator of the MAVEN mission heading off to Mars. That's all for this edition of How on Earth. Today's show was produced with the help of Shelley Schlender. Tim Morton wrote our theme music. Tom Wassinger produced it. Additional music by Jeff Beck.
Our website is hoe.kgnu.net. You can also find it through the main kgnu.org website. Questions or comments, call the KGNU comment line at 303-447-9911. For How on Earth, the KGNU Science Show, I'm Ted Burnham.
And I'm Joel Parker.